Welcome back to Science and Slumber, the place where we explore the quiet wonders of the universe as you drift peacefully to sleep. Tonight, we're going on a slow, soothing journey to trace the path of a silent visitor to our solar system, a traveler from an unknown star. And as we follow its long, lonely path, we'll ask a simple question. What is 3I, Atlas, and where did it come from? It sounds simple, but the deeper you fall into it, the more you realize you are asking about the history of other stars, of distant unseen worlds, and the vast, quiet emptiness in between. I hope this story helps you drift off into a deep and restful sleep, but if you choose to stay awake for a little while, I hope it keeps you pleasantly curious, wrapped in a sense of quiet wonder. Before we begin, if you feel you have a moment, a gentle tap on the like button, and perhaps a quiet click on subscribe would be wonderful. It doesn't make a sound, but it quietly helps this sleepy little channel grow and reach other minds in need of rest. Wherever you are, settle in now, get comfortable, let go of the day. There's nothing you need to do, nothing to remember. Just let the words wash over you. Let them be like the gentle solar wind, pushing all thoughts aside. Ready? Here we go. Before we can speak about 3I, Atlas, we must first understand the place it visited. We must understand the shape and feel of our own home, our solar system. Imagine it not as a collection of spinning rocks in a vacuum, but as a vast and ancient river flowing in a slow, circular current through the quiet of space. It is a river of immense darkness, its waters the gentle, invisible pull of gravity. At its center there is no great noise, no violent churning, but only a deep, steady and immensely powerful eddy. This is our Sunday. It doesn't burn the water, it simply is the water's destination and its source of motion, the point around which everything quietly revolves. The sun's gravity is the river's, the current, a silent, patient force that has guided everything here for billions of years. Settle into this image. Feel the profound stillness of this cosmic river. Along the riverbed, in perfectly worn grooves, lie the planets. They are like massive, smooth stones, so heavy and ancient that they have settled into their paths for eternity. Mercury, Venus, Earth, Mars, they are the inner stones, warmed by the central eddy. Further out, in the colder, slower-moving water, lie the gas giants Jupiter and Saturn like colossal, banded boulders, their presence so immense they create their own smaller, gentler currents, pulling moons along with them like tiny grains of sand. Their paths are not chaotic, they are the definition of serene predictability. For all of human history, and for eons before, they have followed the same gentle circular course, held fast by the river's inescapable flow. They belong here, this is their home. And then, there are the comets. In this river, they are not sudden, terrifying intruders. They are more like ancient icy pebbles, countless in number, that belong to the same river system. They don't follow the deep, simple grooves of the planets. Instead, they travel on much wider, more elliptical currents, as if swept up in a long, slow loop that takes them from the misty, dark headwaters of the river, far, far from the center. On a patient journey inward, they fall toward the sun, feeling its warmth for a little while, and then the current gently carries them back out again, back toward the cold and the dark from which they came. They may disappear for thousands, even millions of years, but their path is still a loop. They are still bound to this river. They always return. In other words, everything we know in our solar system is family. From the largest planet to the smallest, dustiest comet, everything is caught in the same gravitational embrace. They are all tethered, all part of the same gentle cosmic dance. The shape of the journey is always a closed circle, or a long, stretched-out oval, an ellipse. It is the signature of belonging, the family crest of anything born in the currents of our Sunday. To see a comet in our sky was once a sign of chaos to ancient eyes, an omen of change, but we now know its journey is one of profound order. It is just a distant member of the family, coming home for a brief visit before heading back to the quiet outer reaches. This is the great, calm truth of our solar system. It is a place of return, a self-contained ecosystem of gravity and light, where nothing is truly a stranger and no path leads away forever. But this great celestial river has its source, a place of unimaginable quiet and darkness far beyond our sight, and the story of our comets begins there, at the very edge of the sun's gentle hold. To find the source of this great celestial river, we must travel outwards, far beyond the familiar lights of the planets. We journey past the orbits of Neptune and Pluto, into a darkness so profound that our sun shrinks behind us, becoming just the brightest star in an ocean of unblinking light. We are moving now into a place that no human eye has ever seen, a place that exists in our minds as a beautiful, necessary idea. It is a place imagined by a Dutch astronomer named Jan Oort, who, like a detective studying the paths of rivers, traced the comets back to their source and realized there must be a vast, unseen reservoir. He gave it his name, the Oort cloud. Imagine a sphere of perfect frozen silence surrounding our entire solar system. It is not a cloud of gas, but a scattered, impossibly vast globe of icy bodies. Trillions of them, each one a sleeping comet, a mountain of frozen gas and dust left over from the birth of the Sunday. They float in a state of near-perfect stillness, held in a delicate gravitational balance, captured by the sun's influence, but so far away that its pull is almost imperceptible. This is the cosmic seed bank of our solar system. The air here, if there were any, would be colder than anything we can truly imagine. The silence would be absolute. From here, the grand dance of the planets is just a tiny, intricate clockwork, impossibly distant and small. This is where the icy pebbles of our river are born. For millions, even billions of years, they drift in this silent darkness, waiting. They are not on a path anywhere. They are simply suspended, part of a great, quiet whole. But the galaxy is not entirely still. Occasionally, another star will pass in the far, far distance. Its journey doesn't bring it close enough to be seen as more than a moving pinprick of light, but its gravity washes over the Oort cloud like a silent, gentle wave. It is a whisper, a nudge so faint it can barely be called a force, but in this place of perfect balance, a whisper is enough. One of those sleeping, icy mountains is disturbed. Its delicate orbit is broken, and it begins to fall. In other words, the comets that grace our skies are not random wanderers. They are our own. They are fragments of our solar system's birth, sent on a pilgrimage from its most distant and ancient edge. Their journey is one of incredible patience. For 1,000,000 years, 2,000,000 years, they fall, slowly accelerating as they travel from the cold, dark headwaters of the celestial river toward the warm, bright center. The journey is so long it makes all of human history seem like a single heartbeat, and yet, throughout that entire fall, they are still fundamentally connected to our Sunday. They are part of its domain. What this really means is that our home doesn't end with Pluto. Our true front porch extends thousands of times further, a vast sphere of influence that brushes against the edges of other star systems. So every comet from this cloud, every icy pebble, belongs to our sun's river. The real turning point, however, hides in something gentler, the quiet, invisible nature of that connection itself. That gentle, invisible connection is gravity, the sun's steady hold on everything in its domain. It's a concept we understand with our minds, but it's hard to feel in our bones. So let's not think of it as a force, but as a vast, quiet harbour at the edge of an infinite ocean. In the centre of this harbour is a great, warm lighthouse, our Sunday. And every object born in this harbour, from the largest ship to the smallest wooden dinghy, is tethered to it by an invisible rope. The planets are like great heavy barges, moored on very short, very strong ropes. They circle the lighthouse in tight, predictable paths, never straying. They feel the pull constantly, a steady, reassuring tug that keeps them safe and secure in the calm waters of the harbour. The comets from the Oort cloud are like tiny, ice-covered skiffs, tied to the lighthouse with ropes that are impossibly long, stretching for miles and miles into the misty darkness at the harbour's edge. For most of their existence, they float almost freely, the ropes so slack they barely feel a pull. They drift in the calm, dark waters, barely moving, but the rope is still there. It is never broken. and when some gentle current, the passing of a distant star, nudges one of these skiffs, it begins to drift inward toward the lighthouse. The journey is slow at first, the rope gradually tightening over thousands of years. As it gets closer, the pull becomes stronger, guiding it faster and faster toward the warm central light. It rounds the lighthouse, feeling its heat, and then its momentum carries it back out again, swinging it wide back toward the darkness. The rope plays out, growing slack once more, but it never lets go. The little skiff will eventually slow, stop, and one day perhaps begin its long journey back. This is what it means to be in orbit. It is to be tethered. The invisible rope of gravity ensures that no matter how far an object travels, it is destined to return. The harbour of our solar system is a closed system. Nothing leaves forever. The ropes are all of different lengths, creating orbits of different sizes and shapes, but they are all fundamentally connected to the same central point. This harbour is a place of belonging. It is a family of objects, all held together by the same quiet, persistent law. There's something beautifully poetic about this idea that in a universe of seeming chaos, our little corner of it is defined by a gentle, inescapable loyalty. So, when astronomers see a new object in the sky, the first thing they do is try to understand the shape and length of its rope. By watching its path for a few nights, they can map its journey. They can see how it is moving in relation to the lighthouse. They can tell if its rope is short, like Earth's, keeping it in a near-perfect circle, or if its rope is long and stretched, like a comet's, sending it on a vast looping voyage. For centuries, every single object we ever observed, every planet, every asteroid, every comet, was found to be on a rope of some kind. They were all members of the harbour. They all belonged to our Sunday, until, one day, we saw a ship sailing through the harbour that had no rope at all, and the map bends in a way we don't expect. That invisible rope of gravity doesn't just hold an object, it dictates its entire journey. It draws the map that the object must follow for all of time. Imagine this path not as an invisible line, but as a glowing track etched into the fabric of space, a silent, luminous circuit. For every object in our solar system, that track is a closed loop. It is a shape that always, eventually, returns to its beginning. A planet, like the Earth, follows a track that is almost a perfect circle, a simple, steady, and constant journey around the Sunday. It is like a runner on a perfectly round course, passing the same scenery with every lap, year after year, in a rhythm of absolute dependability. There is a deep, primal comfort in this predictability. It is the rhythm of our seasons, the foundation of our calendar, the metronome of life itself. A comet from the Oort cloud follows a very different kind of track. Its loop is stretched into a vast, elongated oval, an ellipse so extreme it barely looks like a loop at all. Imagine our runner on a track that is miles long but only a few feet wide. They spend almost their entire journey running in a near straight line away from the start into the far distance, slowing as they go. Then, at the very end, they make a tight, fast turn and run all the way back, accelerating toward the finish line, which is also the starting line. The journey is long, lonely, and takes millennia to complete, but the fundamental truth remains. The track is a loop. The path is closed. The runner, eventually, always comes home. For centuries, this was the only kind of story we knew how to read in the sky. It was a German astronomer, Johannes Kepler, sitting patiently in the early 1600s, who first realized this deep truth. After years of watching the quiet dance of the planets, he saw that their paths were not perfect circles as everyone had believed, but these gentle, elegant ellipses. He discovered the family secret. In other words, the shape of an object's path is its passport. If it follows a closed loop, a circle, or an ellipse, it is a citizen of our solar system. Its orbit is a quiet declaration that it is bound to our sun, held by that invisible rope, no matter how long or frayed it may seem. This orbital signature is a promise of return. It is the telltale path that says, "I belong here." It is the universe's most graceful and predictable design, a law written in the language of curves and gravity. ensuring order and stability in our cosmic home. Every single thing we had ever observed followed this rule. It was the unwavering foundation of celestial mechanics, as reliable as the dawn. This familiar, looping path was the only signature we knew, the only kind of journey we had ever witnessed. It was the only celestial footprint we had ever seen. But the real turning point hides in something gentler, the discovery of a footprint that was shaped very differently. Imagine you are walking on a vast, empty beach in the pale silver light of dawn. The air is cool and still, and the only sound is the gentle, rhythmic hush of the waves sighing against the sand. The beach is a perfect, untouched canvas, smoothed by the last high tide. Behind you, your own footprints trail away, a clear and simple record of your journey from the dunes. Further down the shore, you see the delicate three-pronged tracks of a sandpiper, a familiar little dance etched into the wet sand. These prints all tell a story of this place. They belong here. They are the expected looping paths of the beach's residents. But then, you see something else, a new set of footprints. They are unlike any you have ever seen. They are not the prints of a bird or a dog or a human. They are deep, smooth impressions in the sand, and their story is what truly stops you. The trail doesn't begin from the dunes behind you, nor does it run parallel to the water. It emerges directly from the surf, a straight and determined line coming out of the vast grey ocean. It crosses the entire width of the beach without turning, without pausing, and disappears into the tall grasses on the other side, never to return to the sea. There is a quiet electric thrill in this discovery. You are standing in a familiar place, but you have just found proof that it was visited by something utterly unknown, a traveller from a different world, just passing through. This is the very same feeling that astronomers experience when they find an object on a hyperbolic path. For centuries, every track they saw was an ellipse, a closed loop, the signature of a celestial resident. But a hyperbolic path is different. It is an open curve. It is the footprint of a wanderer. An object on such a path comes from the deep ocean of interstellar space, moving with so much speed that the sun's gravity cannot capture it. It is not tethered by any rope. It sails straight through our harbour, its path bent slightly by the lighthouse's pull, but its momentum is too great. It makes its closest approach, swings around the sun in a wide, graceful arc, and then continues on its journey, heading back out into the infinite darkness, never to be seen again. In other words, the shape of this path is a definitive statement. It is a signature of farewell. An object on a hyperbolic path is not a member of our solar system's family. It is a visitor, a tourist from another star. Its incredible speed is the giveaway it's moving too fast to have been born here. It carries with it the momentum of its ejection from some other, distant stellar system. What this really means is that our solar system is not an isolated island. It is a shoreline on a vast cosmic ocean, and things can, and do, wash ashore from other lands. The discovery of such a path is the discovery of a tangible connection to the rest of the galaxy. It is the quiet, stunning realization that we are not alone in our little harbour, and that the universe is a place of journeys, not just destinations. For a long time, this new kind of footprint was just a beautiful theory, and then, in the quiet of a summer night, a patient eye scanning the darkness finally saw one. Our story now takes us to a quiet mountaintop, under a vast dark sky pierced by the silent river of the Milky Way. Here, there are no bustling cities, no ambient glow of electric light, just the gentle hum of machinery in the cool thin air. This is the home of the Atlas Survey, the Asteroid Terrestrial Impact Last Alert System. Its name sounds urgent, but its work is one of quiet, methodical patience. It is a network of small, robotic telescopes, standing like silent sentinels in observatories scattered across the globe, from Hawaii to Chile to South Africa. They are not built to stare deeply into one patch of sky, searching for the secrets of creation. Their task is simpler, and yet no less profound. Every night, as soon as the sun's last glow has faded, their domed roofs slide open, and their electronic eyes begin to scan. Imagine these telescopes not as complex machines, but as incredibly patient night watchmen. Their job is to create a motion picture of the entire night sky. They take a picture of a vast section of the heavens, and then a few minutes later, they take the exact same picture. Then a computer, with a calm, tireless mind, compares the two. All the distant stars and galaxies remain perfectly still, a fixed and silent backdrop. But against that backdrop, anything that is closer, anything that belongs to our own solar system, will have moved. It is a simple, elegant way to find the moving things in the dark, the asteroids and comets that are our nearby neighbours. For years, this is all they found, the familiar residents of our celestial harbour, each one following its own predictable looping path. But on the night of the 1st of July, 2025, one of these quiet eyes, stationed at the El Source Observatory in the sparse, beautiful landscape of Chile, noticed something new. In a sequence of images, there appeared a faint, fuzzy smudge of light. It was moving, as expected, but it was moving differently. It was moving fast, faster than a typical asteroid. And its path was not quite right. The initial data points suggested a trajectory that was unusually straight, as if this object was not gently looping around the sun, but rather hurtling through the solar system on a journey of its own. There was no sudden alarm, no frantic discovery. It was a quiet digital flag raised in a stream of endless data. A human astronomer, checking the system's findings, would have seen the notification not as a shocking revelation, but as a gentle, intriguing puzzle. More observations were needed. Other telescopes around the world were quietly alerted, their own robotic eyes turning to this faint, fast-moving stranger to gather more data points, to trace its path with greater certainty. With each new observation, each new point plotted on the celestial map, the picture became clearer. The path was not a loop, the footprint was not one of our own. What this really means is that the discovery wasn't a single dramatic moment of eureka. It was a slow, dawning realization, built by a global collaboration of silent machines and patient minds. It was the quiet confirmation of something long suspected but rarely seen. The night watchmen, in their endless, patient scanning, had finally caught a glimpse of a ship sailing through the harbour with no rope. And the next step would be to give this strange new visitor a name. And so, the visitor was given a name. Not a name from ancient myth, like Jupiter or Mars, but a modern, technical designation that tells a quiet story of discovery. It was named 3I Atlas. Each part of that name is a chapter in its brief but wondrous passage through our lives. The I stands for interstellar. It is a quiet, official declaration that this object is not one of ours. It is a foreigner, a wanderer from the space between the stars. It is only the third such object ever to be confirmed, and so it bears the number 3. Before it came a mysterious rocky object named Oumuamua, and then a more familiar-looking comet named Borisov. Our visitor, 3I, Atlas, is the third whisper from the great dark ocean, the third confirmed piece of another star system to ever grace our skies. The name Atlas is a tribute to the patient, robotic eyes that first spotted it, the Atlas survey. It's a name that speaks not of a single heroic discoverer, but of a quiet, persistent system, a network of sentinels watching the dark. It is a testament to a new way of exploring the cosmos, where discovery is often made not by a human eye pressed to a lens, but by a gentle, intelligent algorithm sifting through mountains of silent data, looking for the one thing that doesn't belong. The name itself is a quiet nod to the patient, collective effort of modern astronomy. To truly feel the weight of this, let's return to our beach at dawn. You see the strange alien footprints leading from the ocean to the dunes. You know you have found something extraordinary. Now, imagine you find something else washed up on the shore, right where the footprints begin. It's a bottle, sealed with wax, and inside there is a message. The bottle itself is made of a strange, unfamiliar glass, and the note inside is written in a script you cannot read. You don't know what it says, you don't know who sent it, and you don't know where it came from, but you know, with absolute certainty, that it is a piece of another world. It is a tangible link to a place beyond your own horizon. This is 3I, Atlas. It is a message in a bottle from an unknown ocean. We cannot read its message in a language of words, but we can study the bottle itself, its composition, its temperature, the way it glows in the light of our Sunday. It is a physical sample of another star system, delivered to our doorstep by the gentle currents of the galaxy. It is a gift of pure discovery, a quiet invitation to wonder about the nature of its home. The name 3i, Atlas, is, in essence, the catalogue number for this message, a simple label on an object of profound and beautiful mystery. What this really means is that the universe has, in its own slow and silent way, reached out to us. It has sent a messenger. The core idea, the very first ripple of this discovery, is simply this: our solar system is not alone. We are part of a vast, interconnected galaxy, and the proof is no longer just a theory. It is a faint, fuzzy smudge of light, moving quickly and quietly through our skies, and the most compelling evidence of its foreign nature was the simple, elegant shape of its path. The path of 3i, Atlas, was the first and most profound clue to its identity. It was a perfect, sweeping arc known as an extreme hyperbola. Let's return to our quiet harbour one last time to truly feel what that means. We have seen the familiar boats of our solar system, all tethered to the central lighthouse by ropes of gravity. The planets are on short, strong ropes, making tight, predictable circles. The native comets are on immensely long, elastic ropes, swinging far out into the darkness and then returning. But 3i, Atlas, sailed into this harbour with a speed and a direction that defied this entire system. It was moving at over 130,000 miles per hour relative to the Sun, a velocity so immense that no gravitational rope could ever hope to catch it. Imagine a ship with sails of impossible size, catching a gale-force wind from the deep ocean. It doesn't drift into the harbour, it slices through it. The lighthouse's gravity, its gentle pull, has an effect. The ship's path is not a perfectly straight line. It bends, curving gracefully toward the light as it passes. But its momentum is simply too great. The harbour's gentle currents can only influence its trajectory, not capture it. The ship never slows enough to be caught, never circles back to drop anchor. It makes its closest approach, a swift and silent passage past the central light, and then its immense speed carries it away, back out into the open ocean on the other side, its path a mirror image of its arrival. This is the journey of 3i, Atlas. Its path is a fleeting, open-ended signature of a traveller just passing through. This incredible speed is the key. It is the visitor's cosmic fingerprint. An object born in our own Oort cloud, even at its most distant edge, is essentially starting from a standstill relative to the Sunday. When it begins to fall inward, all of its final speed is gained from the Sun's gravity alone. There is a cosmic speed limit for everything that belongs to our harbour. 3i, Atlas, shattered that limit. To be moving that fast, it must have arrived with a huge amount of initial velocity. It was already travelling at incredible speed, before it even entered our solar system. In other words, it wasn't just drifting in interstellar space and happened to wander in. It was actively flying through the galaxy. This tells us that its journey didn't begin in quiet stillness. Its story starts with a powerful, energetic event somewhere else, a long, long time ago. Its hyperbolic path is a quiet mathematical echo of a violent beginning in a place we can only imagine. What this really means is that 3i, Atlas, was never ours. Its loyalty, its gravitational allegiance, belongs to the galaxy itself, not to our Sunday. Its brief passage through our solar system is a tiny incidental chapter in a much grander, much longer journey. The shape of its path is more than just geometry. It is a declaration of independence. It is the clear, unambiguous evidence that we are looking at a ghost, a remnant from a home that is not our own. And the most immediate question this raises is a simple one. If this is a ghost from another home, what did that home look like, and why was it cast out? The anachronistic speed of 3i, Atlas, the defining feature of its untethered path, tells us more than just where it's going. It whispers a fragmented story about where it came from. An object does not acquire such a velocity by itself. It cannot be born moving that fast. Such immense momentum has to be given to it. It has to be thrown. This is the immediate and perhaps most wondrous consequence of its journey. 3I, Atlas, was not just a visitor, it was an exile, cast out from its home star system with incredible force. Let's imagine that home system for a moment. Let it form in your mind, a gentle speculative scene. Perhaps it was a system much like our own, with a bright, warm star at its center. Young planets were forming in a disk of dust and gas, coalescing from countless smaller bodies. In the colder, outer reaches of this nascent, the system, icy objects, comets, just like the ones in our Oort cloud, were drifting in gentle, stable orbits. For millions of years, this was the home of the object we now call 3I Atlas. It was a place of quiet, predictable belonging. But solar systems are not always serene. Especially in their youth, they can be violent, chaotic places. Imagine, in this distant system, a giant planet, a world many times the mass of our Jupiter, was also forming. Its immense gravity dominated the outer regions, its orbit slowly shifting and migrating as it settled into its final place. In its slow, powerful dance, its path intersected the quiet, stable orbit of our small icy object. The little comet was caught in the giant planet's gravitational field, like a small boat caught in the wake of a massive ocean liner. It wasn't a collision, it was a gravitational slingshot. The comet swung around the giant planet, and in that brief, powerful exchange, the planet acted like a colossal, cosmic bat. It transferred a tiny fraction of its own immense orbital energy to the small, icy body. The comet was flung away, accelerated to a speed far beyond its home star's escape velocity. Its rope of gravity was not just stretched, but snapped. In a single, silent, violent moment, it was ejected from its home forever, cast out into the great dark void between the stars. In other words, 3I, Atlas, is likely a ghost of a planetary system's tumultuous childhood. It is a fossil of a moment of immense gravitational chaos that happened millions or perhaps billions of years ago, around a star we will never be able to identify. Its high speed is a scar, a memory of the powerful kick that sent it on its way. What this really means is that our visitor carries a story of creation and violence. It is a piece of another world's history, a silent witness to the game of cosmic billiards that shapes young solar systems. We look at it and see not just a comet, but the aftermath of a planetary migration, the ghost of a gravitational upheaval. As it sailed through our own, relatively calm and stable solar system, it was a quiet reminder that not all cosmic homes are as peaceful as ours is today. And as this ghost drew closer to our sun, for the first time in an unimaginable stretch of time, it began to feel warmth, and it began to wake up. As 3I, Atlas journeyed deeper into our solar system, closer to the warmth of our sun, astronomers turned their most powerful eyes toward it. Telescopes like the Hubble Space Telescope, orbiting high above the distortions of Earth's atmosphere, were able to get the first truly clear, albeit distant, glimpse of this interstellar traveller. And what they saw was not a sharp, crisp point of light, like a star or an asteroid. Instead, they saw something beautifully ethereal. It was a soft, fuzzy, hazy glow, a small, luminous cloud moving against the black velvet of space. This gentle, glowing shroud is called a coma, and its presence was the second major revelation about our visitor's identity. It told us, with certainty, that 3I, Atlas, was a comet. Let's imagine this object's long journey. For millions, perhaps billions of years, it has been drifting through the absolute cold of interstellar space. The temperature in that vast emptiness is only a few degrees above absolute zero, a cold so profound that all of its substance was frozen solid, as hard as rock. It was a silent, sleeping mountain of ice, dust, and frozen gases, a perfectly preserved relic of its birth. But now, after an eon of winter, it was flying toward a star, our star. As it crossed the orbit of Jupiter, and then Mars, the faint, distant sunlight began to touch its surface. For the first time since it was violently cast out of its home, it felt warmth. Imagine a traveller from a land of permanent ice stepping into a warm room for the very first time. The feeling is gentle at first, but transformative. The ancient Ix on the comet's surface, exotic materials like frozen carbon dioxide, nitrogen, and carbon monoxide began to stir. They didn't melt from solid to liquid. In the vacuum of space, they sublimated, turning directly from a solid into a gas. This gas, infused with dust that was trapped in the ice, erupted from the surface in gentle, silent plumes, forming a vast, glowing atmosphere around the solid nucleus. This atmosphere, this coma, is what we see from Earth. It is the comet waking up. In other words, the fuzzy glow of 3I, Atlas is the sign of its reanimation. It is the visible breath of an ancient, frozen world, exhaling for the first time in an unimaginable age. The sunlight illuminates this cloud of gas and dust, causing it to shine with a soft, borrowed light. We are not seeing the object itself, but rather the beautiful temporary aura it creates as it responds to the gentle heat of our Sunday. There's something quietly poetic about this idea. This visitor, a refugee from a long-lost star system, spent eons in a state of suspended animation, a silent and unchanging piece of another world. And in its brief passage through our home, our sun's gentle warmth was enough to awaken it, to make it bloom in the darkness. We were fortunate enough to be here, at this exact moment in its endless journey, to witness this fleeting, beautiful transformation. The coma was not just a physical phenomenon, it was a greeting. And within that glowing, hazy light, there was a message waiting to be read. That soft, hazy glow of the coma was more than just a beautiful sight. It was a letter, written in a language of light, carrying secrets from our visitor's distant, unknown home. To read this letter, astronomers used a wonderfully elegant tool called spectroscopy. The concept is simple, yet the results are profound. It allows us to analyze light by breaking it down into its constituent colors, like a prism creating a rainbow. But the rainbow of light from a comet's coma is not a perfect, continuous spectrum. It is crossed by tiny, dark lines and bright, sharp bands. These are the chemical fingerprints of the elements and molecules that are present in the gas. Each element, whether it's carbon or oxygen or sodium, absorbs and emits light at very specific, unique frequencies. By studying the pattern of these lines, we can determine exactly what the comet's coma is made of. Imagine you are standing on a quiet shoreline and a gentle breeze begins to blow from across the ocean. The air carries with it a scent you have never experienced before. It is the smell of the distant, unseen land from which the wind has travelled. Perhaps you can detect the faint, sweet fragrance of unknown flowers, the rich, loamy smell of a strange soil, or the sharp, mineral tang of a volcanic shore. You cannot see that land, but you can learn something fundamental about its nature just by breathing in the air it has sent you. Spectroscopy is a way of smelling the universe. It is the art of reading the messages carried on the wind of light. When astronomers pointed their spectrographs at 3I, Atlas, they were for the first time breathing the air of another solar system. The light from the sun would travel millions of miles, strike the gas and dust in the comet's coma, and then a tiny fraction of that reflected light would continue its journey, travelling millions of miles more until it was collected in the mirror of a telescope on Earth. In that light was the signature of the materials sublimating from the comet's core. Was this visitor made of the same things as our own comets? Was the recipe for building worlds the same in its home as it is here? These were the quiet, wondrous questions that astronomers hoped to answer. In other words, the light from the coma was a direct chemical sample. It was a list of ingredients from a kitchen light years away. By reading the spectral lines, scientists could identify the molecules that had been frozen in that icy nucleus for billions of years, a pristine, the sample of the primordial cloud from which its home star and planets were born. It was a form of cosmic archaeology, using light to excavate the history of a world we can never visit. What this really means is that our visitor was not just a silent traveller, it was a storyteller. Its coma was the ink, and the light was the page. For the brief period it was awake and glowing in our solar system, It was broadcasting the chemical story of its origin across the void, and we, with our patient instruments, were here to listen. And the story it told contained a few quiet, but very surprising words. As astronomers carefully read the story written in the light of the coma, they found many familiar words. There were the clear signatures of cyanogen, a simple molecule of carbon and nitrogen, commonly seen in the comets of our own solar system. There were traces of the hydroxyl radical, a fragment of water, suggesting that 3I, Atlas, like our comets, was rich in frozen H2O. These familiar signatures were, in their own way, deeply comforting. They hinted at a universal chemistry, a shared heritage across the stars. The basic building blocks for worlds, it seemed, were much the same everywhere. The message in the bottle was written in a recognizable alphabet, but as they looked closer, they found something unexpected. The dialect was strange. The light revealed an unusually high abundance of carbon dioxide ice. Our own comets have carbon dioxide, of course, but 3I, Atlas seemed to be releasing it in far greater quantities and much earlier in its journey than a typical comet from our Oort cloud. Even more surprising was the clear, sharp fingerprint of vaporized nickel. While metals like iron and nickel are found in the dust of our comets, detecting them in the gas of the coma is rare, and the amount seen in 3I, Atlas, was significant. Let's return to that message in a bottle, washed up on the dawnlit beach. At first, you recognize the alphabet. You can make out familiar letters. But as you try to read the words, you realize the spelling is strange, the grammar is unlike anything you know. And some of the words, some of the chemical phrases, are completely new. The presence of so much carbon dioxide and gaseous nickel was like finding a word that doesn't exist in your language. It was a clue, a subtle but profound one, that the place this message came from had a very different environment from the one that shaped our own solar system. In other words, the chemical signature of 3I, Atlas, was a mixture of the familiar and the deeply strange. It was like a cousin from a distant, unknown branch of the cosmic family, who shares the family resemblance but speaks with a thick, unfamiliar accent and has stories of a life we can barely imagine. The overabundance of carbon dioxide might suggest it was formed in a much warmer part of its home star's protoplanetary disk than our comets were. Or perhaps its parent star had a different chemical composition altogether, enriching the entire system with different ratios of elements. What this really means is that 3I, Atlas, was more than just a piece of another world. It was a clue to the diversity of worlds. It quietly challenged the assumption that all solar systems form in the same way. The universe, it seemed, had more than one recipe for making comets. This visitor wasn't just a confirmation that other worlds exist. It was a subtle, beautiful hint that those worlds might be wonderfully, fundamentally different from our own. And this chemical strangeness was not the only clue. Its very path through the galaxy hinted that it was not just from another place, but from another time. The path of 3I, Atlas told a story not just of its ejection from a distant star, but of its long, meandering journey through the Milky Way. By carefully tracing its trajectory backwards, projecting its path into the deep past, astronomers could get a sense of where it came from, not the specific star, which is impossible to pinpoint, but the general neighborhood of the galaxy it once called home, and what they found was another layer of profound mystery. Its path suggested it did not originate from the part of the galaxy where our sun resides, the so-called thin disk. Instead, its journey seemed to begin in a much older, more diffuse region known as the thick disk. To understand this, imagine our Milky Way galaxy not as a flat spinning plate, but as a sprawling, ancient city. Most of the city's inhabitants, including our sun, live in the bustling, bright and relatively young downtown area, the thin disk. This is where stars are actively being born, where the gas and dust are rich with heavy elements forged in previous generations of stars. It's a dynamic, vibrant, and somewhat crowded place. But surrounding this downtown core is a quieter, more spread-out region of older historic suburbs. This is the thick disk. The stars here are more scattered, their orbits more gently inclined. They are, on average, much, much older. These are the city's first residents, the quiet elders of the galaxy. 3I, Atlas's trajectory, its high speed and inclined path relative to the galactic plane, was like a fingerprint, indicating it was a resident of one of these ancient quiet suburbs. It wasn't just from another star, it was likely from a star that is billions of years older than our own Sunday. Our Sun is about 4.6 billion years old, a relative newcomer. The stars of the thick disk can be twice that age, 10 billion years old or even more. They were born in a younger, wilder version of the universe, when the chemical composition of the galaxy was different. This realization casts our visitor in an entirely new light. It is not just a piece of another world, but a piece of an ancient one. It is a true relic, a fossil from the galaxy's youth. The unusual chemistry that we detected in its coma might not just be a sign of a different kind of solar system, but of a solar system that formed in a completely different cosmic era. It is a messenger from a past so deep it is almost beyond our comprehension. In other words, we were not just looking at a visitor from another place, but a traveller in time. This icy, tumbling mountain was likely already a wanderer in the void for billions of years before the Earth itself had even finished forming. It drifted through the darkness while dinosaurs roamed our planet, and it was still drifting when the first humans looked up at the stars, never knowing that a piece of a far older world was silently making its way toward them, and the journey itself, that immense, quiet voyage, adds a final meditative layer to its story. Let us now leave behind the calculations and the chemical signatures, and simply float for a while in the quiet, profound emptiness of interstellar space. Let us join our ancient traveller on its long journey. After being flung from its home, a violent and chaotic birth into exile, its existence settled into a rhythm of almost perfect silence and stillness. For millions, perhaps billions of years, it moved through the void between the stars. The darkness here is unlike anything on Earth. It is a complete and total blackness, punctuated only by the distant, cold pricks of starlight, unblinking and unwavering, with no atmosphere to make them twinkle. Imagine our comet, a silent, solitary mountain of ice and rock, tumbling slowly through this void. Its speed is immense, but in the sheer vastness of space, there is no sensation of movement. There is no wind, no friction, no sound. Its journey is a perfect frictionless glide through an ocean of absolute zero. Days, years, centuries, millennia, these measures of time lose all meaning. The comet does not age. It does not change. Frozen in the cryogenic cold, every molecule of its being is locked in a state of suspended animation. It is a perfect time capsule, preserving the exact conditions of its birth, unchanged for an eternity. Occasionally, over the span of 1,000,000 years, it might pass through a thin, ethereal cloud of interstellar gas, a nebula so diffuse it is less dense than the best vacuum we can create on Earth. For a brief cosmic moment, a few atoms of hydrogen might brush against its surface, but it is too little to leave a mark. For the most part, its journey is one of profound, unbelievable loneliness. The nearest star is a distant, bright point, its warmth utterly unfelt. It is a ship sailing on an ocean with no islands, no other ships, no sign of any shore. It is a messenger with no one to talk to, a traveller with no destination in mind, its path dictated only by the initial momentum of its violent expulsion and the faint, collective gravity of the galaxy itself. There's a deep, meditative peace in contemplating this journey. In our own lives, time is a river that flows relentlessly forward, marked by change and decay. But for 3I, Atlas, time was a frozen lake. It existed outside of time as we know it, a silent, unchanging monument to a world that may no longer exist. The star that gave it birth may have long since died, its sibling planets may have been destroyed or scattered, but this one small fragment, this exile, survived, carrying the memory of that lost world within its frozen heart. What this really means is that the object we see in our sky is not just a comet, it is a survivor. It has endured a journey so long and so empty that it defies human imagination. Its brief, fiery passage near our sun is a momentary dramatic awakening in an existence defined by an almost infinite sleep. We are witnessing the one single moment of activity in an eternity of quiet, and as we watch this ancient survivor, we were reminded that it was not the first of its kind to pay us a visit. It was merely the latest in a series of quiet cosmic messengers. Our ancient visitor, 3I, Atlas, did not arrive in a vacuum of understanding. It was the third in a slow, steady trickle of messengers from the interstellar deep, each one adding a new sentence to a story we are only just beginning to comprehend. Before Atlas, there were two others, each with its own distinct and mysterious personality. Thinking of them together helps us appreciate the quiet wonder of what we are witnessing. It's like finding three different bottles washed up on the shore, each from an unknown land, each with a unique message inside. The first was discovered in 2017 and given the beautiful Hawaiian name Oumuamua, meaning a messenger from afar arriving first. It was a true enigma. It was small, rocky, and strangely elongated, perhaps shaped like a cosmic cigar or a flat, tumbling shard. As it sped through our solar system, it showed no signs of a coma, no fuzzy glow of sublimating gas. It was a dark, inert piece of rock or metal, not an icy comet. It even accelerated slightly as it left, pushed by a gentle, unseen force that some speculated could be outgassing we couldn't detect, or something far stranger. Oumuamua was a complete mystery, a message in a bottle written in an indecipherable language, leaving us with more questions than answers. It was a whisper of how truly alien other worlds might be. Then, just 2 years later, came the second visitor, 2I Borisov. This one felt more familiar. It was, unmistakably, a comet. It had a bright, beautiful coma and a long, sweeping tail. Its chemical composition, when studied through spectroscopy, was remarkably similar to the comets from our own Oort cloud. Borisov was like a message in a bottle written in a language we could understand. It was a comforting find, suggesting that comet-like objects similar to our own might be common throughout the galaxy. It hinted at a shared universal process of solar system formation. It was a quiet reassurance that perhaps we weren't so different after all. And then came 3I, Atlas. It was the third message, and it complicated the story in the most wonderful way. It was clearly a comet, like Borisov, but it was much larger, much faster, and its chemical dialect was subtly but distinctly strange. It was neither the complete enigma of Oumuamua nor the comforting cousin of Borisov. It was something in between, a bridge between the familiar and the utterly alien. Its great age, hinted at by its origins in the galactic thick disk, added a layer of history that the others lacked. In other words, these three visitors, taken together, paint a picture of a galaxy that is both reassuringly familiar and breathtakingly diverse. They are three random samples from a cosmic ocean teeming with countless other wanderers. They tell us that the galaxy is constantly seeding itself, flinging pieces of solar systems out into the void, and that these pieces come in all shapes, sizes, and compositions. One might be a rocky fragment of a planet's core, another a classic icy snowball, and another an ancient relic from a bygone era. They are the driftwood of the Milky Way, each with its own story of a distant, unseen storm, and the story of Atlas itself held its own quiet paradoxes. One of the most gentle and intriguing paradoxes about 3I, Atlas, was its surprising liveliness. Comets are creatures of warmth. They wake up and form their beautiful glowing comas as they get close to the sun, where the solar radiation is strong enough to sublimate their surface ices. For a typical comet from our own solar system, this process begins in earnest somewhere around the orbit of Jupiter, but 3I, Atlas, was different. It began to show a faint but distinct coma when it was still incredibly far from the sun, well beyond the orbit of Saturn. At that immense distance, the sun is just a brilliant point of light, its warmth almost negligible. The temperature on the comet's surface was still hundreds of degrees below freezing. And yet, it was already active. It was already exhaling its ghostly breath into the void. This is the gentle paradox. It was a flower blooming in the depths of winter, What could cause an icy body to come alive in such a profound cold? The answer must lie in the nature of the ice itself. The primary ingredient in our own comets is water ice, which requires a relatively high temperature to sublimate into gas. The early activity of 3I Atlas was a clear sign that its surface was rich in far more volatile ices, materials that turn to gas at much, much lower temperatures. It was coated in a frost of things like frozen carbon monoxide, carbon dioxide, and nitrogen ices that are so volatile they would boil away in an instant if brought to Earth. Imagine you have two blocks of ice. One is made of water, and the other is made of frozen air, or what we call dry ice. In a warm room, the water ice melts slowly, predictably, but the block of dry ice begins to steam and smoke immediately, even in a very cold room, turning directly into a cloud of gas without ever becoming a liquid. 3I. Atlas was behaving like that block of dry ice. Its ancient interstellar journey had perfectly preserved a surface layer of these hypervolatile materials. As it entered the very outer edges of our solar system, even the faintest whisper of the sun's warmth was enough to trigger this gentle, premature awakening. In other words, its early activity was another clue about its origins. It suggested that 3I, Atlas formed in an incredibly cold region of its home star system, a place so frigid that even these most delicate gases could freeze solid and become part of its structure. Or perhaps it was simply a sign of its pristine nature. Having never been near a star before, its original volatile outer layers were perfectly intact, a delicate frosty shell that began to sublimate as soon as its long winter began to end. What this really means is that we were witnessing the very first moments of its reanimation. We were seeing the most delicate, easily disturbed materials burn off first, a quiet introductory chapter to its passage through our solar system. This early blooming was a beautiful, fleeting phase, a hint of the deep frozen secrets that lay within its ancient heart. And as our telescopes looked closer, they saw that even the shape of this early blooming was telling a story of its own. As the Hubble Space Telescope and other powerful observatories focused on the faint, waking glow of 3I Atlas, they revealed a detail of exquisite, subtle beauty. The coma, that cloud of gas and dust surrounding the nucleus, was not a perfect symmetrical sphere. It was not a simple halo of light. Instead, it was gently but distinctly elongated, shaped like a teardrop or the streamlined cowl of a spaceship, with its rounded, brighter edge pointing toward the sun and a softer, more diffuse tail stretching away. This elegant, teardrop-shaped cocoon was a visual representation of the comet's first interaction with our solar system, a silent story being sculpted in real time by the gentle forces of our Sunday. Imagine a single perfect snowflake falling through still air. It is a jewel of six-sided symmetry, pristine and unchanged. But now, imagine that same snowflake falling into a gentle, steady breeze. The air, though invisible, exerts a pressure on it. The snowflake begins to drift, to trail, and perhaps a tiny wisp of its fragile structure is carried away behind it. Its perfect symmetry is broken by its journey through the air. The coma of 3I Atlas was like that snowflake, and the gentle breeze was the constant, almost imperceptible pressure of sunlight itself. This force is known as solar radiation pressure. Light, though it has no mass, carries momentum. When photons of sunlight travel from the sun and strike the tiny dust particles in the comet's coma, they give them a minuscule push, always directed away from the Sunday. It is the gentlest of forces, a touch as light as a whisper, but in the frictionless vacuum of space, over millions of miles, that whisper is enough to shape an entire cloud of dust. The dust particles are gently nudged, herded backwards, away from the sun, creating the soft, elongated tail of the teardrop. The gas in the coma, being made of individual atoms and molecules, is less affected by this gentle push and tends to form a more rounded shape around the nucleus. In other words, the teardrop shape was a compass, its every curve and contour pointing back to our star. It was a beautiful, large-scale visualization of the invisible forces at play in our solar system. We were seeing the sun's light not just as illumination, but as a physical, sculpting wind. This ancient piece of another world, upon entering our home, was immediately being shaped and moulded by it, its pristine, spherical aura being gently combed back into a form that told a story of its new environment. What this really means is that the comet was not just a passive visitor, it was an active participant in a delicate cosmic dance. The shape of its coma was the first step in that dance, a graceful bow to the star it was approaching. It was a quiet, visual poem about the power of gentle, persistent forces. We were watching the sun's light physically touch a visitor from another star, and the evidence of that touch was written in the soft, glowing contours of a celestial teardrop. And this was only the beginning of the story that Shape was telling, for deep within this interaction, a second, more ethereal shape was also beginning to form. As 3I, Atlas, drew closer to the sun, its simple teardrop-shaped coma began to differentiate, blossoming into one of the most elegant and iconic forms in the cosmos, a comet's tail. Or, more accurately, two tails. This dual signature is a subtle and beautiful piece of physics, a celestial fingerprint that tells a story of two different kinds of solar wind. One tail is made of dust, the other of gas, and though they may look similar from Earth, they are born from different forces and point in slightly different directions, a quiet divergence that speaks volumes about the sun's influence. The first tail, the one that is often brighter and more gently curved, is the dust tail. Let's return to our image of sunlight as a gentle, persistent breeze. This breeze, the solar radiation pressure, is what pushes on the tiny, solid particles of dust that are lifted from the comet's nucleus, along with the sublimating gas. These dust particles are like microscopic grains of sand. Once they leave the comet, they are on their own, new little celestial bodies in their own orbits around the sunday. The gentle push from sunlight nudges them away from the sun, but their own orbital momentum, inherited from the comet, causes them to lag behind slightly. The result is a broad, diffuse, and often gracefully curved tail that tends to follow along the comet's orbital path. It is the glowing, dusty wake of the comet's journey. The second tail is fainter, straighter, and often tinged with a ghostly blue light. This is the ion tail, or gas tail. It is not shaped by the gentle pressure of sunlight, but by a much more energetic and entirely different force, the solar wind. The sun doesn't just emit light and heat, it constantly breathes out a stream of charged particles, protons and electrons that flows outwards through the solar system at 1,000,000 miles per hour. When this fierce, invisible wind strikes the gas molecules in the coma, it strips them of their electrons, turning them into charged ions. These ions are then captured by the magnetic fields embedded in the solar wind and are carried straight away from the sun, like smoke caught in a powerful gale. This tail, therefore, always points directly, perfectly away from the sun, regardless of which way the comet is moving. In other words, 3I, Atlas was painting a picture in the sky with two different brushes. The dust tail was a soft, glowing memory of where it had been, tracing its curved path through space. The ion tail was a sharp, straight arrow, a celestial weather vane, showing the precise, real-time direction of the invisible solar wind. Observing these two tails was like watching a ship at sea with both a flag and a trail of smoke. The smoke shows where the ship has been, but the flag shows which way the wind is blowing right now. What this really means is that our visitor became a delicate scientific instrument, a probe sent from another star that, upon its arrival, began to measure and reveal the invisible environment of our own home. Its two tails were a quiet, beautiful lesson in the dual nature of our sun's influence, a silent ballet of dust and gas, light and wind, all performed for us by a traveller who had come so very far. And the path that traveller took through our solar system was, in itself, a journey of quiet, meditative grace. Having journeyed for eons through the uncharted, empty ocean of interstellar space, 3I, Atlas now found itself navigating the intricate, yet predictable celestial pathways of our solar system. Its course was not random. From the moment it entered the sun's gravitational influence, its path was set, governed by the elegant, unwavering laws of celestial mechanics. It was a slow, graceful, and silent ballet, a tour of our cosmic neighborhood, guided by an invisible hand. Let us trace this journey in our minds. Imagine a vast dark room, with the sun as a single warm lamp in the center. The paths of the planets are faint, glowing circles on the floor. Our visitor did not enter along this flat plane, the floor where the planets dance. It came in from above, at a steep angle, diving down towards the light. Its trajectory carried it across the orbit of Saturn, then Jupiter, its speed steadily increasing as it fell deeper into the sun's gravity well. It was an outsider, for a time, looking down on the familiar, clockwork motion of our world. Its path was calculated with incredible precision by astronomers who watched its steady progress night after night. They could see its future, a map of its journey laid out before it. The calculations showed it would cross the orbital path of Mars, a silent passage through the celestial territory of the red planet. It would then continue inward, reaching its closest point to the Sun, its perihelion, somewhere between the orbits of Venus and Mercury. For a brief moment in its ageless existence, it would be bathed in a warmth and light 1,000 times brighter than anything it had ever known, but even at its closest, it posed no threat. Its path was a study in safe distances. It would remain millions upon millions of miles from any planet, a tourist keeping a respectful distance from the locals. There was a quiet comfort in this predictability. In a universe that can often feel chaotic and random, the journey of 3I, Atlas, was a testament to the underlying order of gravity. Its path was a perfect sweeping curve, as pure and absolute as a line in a geometry textbook. We could know with near certainty where it was going, and where it would be years from now. In other words, we were watching a grand, cosmic performance for which we already had the program. We knew the choreography of this celestial ballet. We could anticipate its every move. This allowed us to plan, to point our telescopes at the exact right spot in the sky, at the exact right time, to capture every fleeting detail of its brief, luminous visit. The journey was not a source of anxiety, but a source of calm, meditative observation. It was a chance to simply watch the universe work, to witness the quiet, majestic unfolding of physical law. What this really means is that our solar system, for a time, became a sort of celestial laboratory. 3I, Atlas, was the subject, and its path was the experiment. By observing how its trajectory was gently bent by the gravity of the sun and planets, we could test and confirm our understanding of the universe's most fundamental force. But this perfectly predictable path had one more gentle twist in its story, a quiet moment of disappearance that was, itself, perfectly predictable. There is a quiet and beautiful paradox at the heart of our visitor's journey. The moment of its greatest illumination, the point at which it would be closest to the sun and shining most brilliantly, was a moment we could not see. As 3I, Atlas made its perihelion passage, its tight, graceful turn around our star, it would slip behind the sun from our perspective here on Earth. For several weeks, it would be lost in the dazzling, overwhelming glare of the very object it came so far to meet. Imagine you are standing on a shore at night, watching a distant ship with a single lantern sail across the harbour. In the middle of the harbour is a tall, bright lighthouse. As the ship sails, you can track its steady progress, its light a small, moving star in the darkness. But as its path carries it directly behind the lighthouse, its little lantern is completely swallowed by the lighthouse's powerful beam. The ship hasn't vanished. It is still there, sailing on its predictable course, but from where you stand, it has disappeared from view, its faint light utterly overpowered. It is having a private moment, an intimate encounter with the central light, hidden from your sight. This is precisely what happened with 3I, Atlas. This period is called conjunction. From our vantage point, the Earth, the comet, and the Sun would form a near-perfect straight line, with the Sun in the middle. Any attempt to point a telescope in its direction would be an attempt to stare directly into the Sun, an impossible and dangerous task. So, at the very peak of its activity, when its coma was at its largest and its tails at their longest, 3I, Atlas entered a period of quiet solitude. It was alone with the sun, hidden from the prying eyes of humanity. There's a certain poetry to this. After a journey of perhaps 1 billion years through the lonely absolute dark, our visitor was granted a moment of unobserved communion with the star it was visiting. It was a private audience with the king. During this time it would be subjected to the most intense heat and radiation of its entire journey, a trial by fire that would strip away layers of its ancient ice, revealing deeper, older surfaces. All of this would happen while it was hidden from us, a secret transformation occurring behind a curtain of light. In other words, the climax of the story was a silent one. We, the observers, were forced into a moment of patient waiting. We knew where it was, we knew what was happening to it, but we could not watch. We had to rely on our models, our predictions, our trust in the laws of physics, to imagine the spectacle that was unfolding on the far side of the Sunday. It was a gentle reminder that we are not the center of the story. We are merely fortunate witnesses, and sometimes the most profound moments are not for us to see. What this really means is that the comet's journey contained a moment of pure, unadulterated physics, free from the act of observation. And it deepened the mystery, for when it emerged from the sun's glare on the other side, we would be looking at a changed object. But even before this disappearance, there was another, deeper mystery at its heart, the unseen nucleus, hidden within the glow. At the very center of that beautiful glowing coma, hidden from our view, lies the source of it all, the nucleus. This is the solid physical heart of 3I, Atlas, the ancient icy mountain that is actually making the journey. But for all its importance, it remains a ghost in the machine, an object we can infer but cannot directly see. The very phenomenon that announces its presence to us, its glorious sunlit coma, also serves as a perfect veil, a shroud of its own making that hides its true form from our eyes. Imagine you are standing at the edge of a perfectly still pond in the cool grey light of early morning. A thick silver mist hangs just above the water's surface, clinging to it like a soft blanket. You know that at the bottom of this pond there is a bed of smooth, worn stones. You want to see them, to know their shape, their colour, their size. But the mist obscures everything. You can see the surface of the water, and you can see the light reflecting off the mist, making it glow, but the depths remain a complete secret. Now, as the sun rises higher, its warm light touches the pond. You might expect the mist to burn away, clearing your view. But instead, the warmth causes the pond to release even more vapour, and the mist grows thicker, brighter, and more opaque than before. The very thing that should reveal the pond's secrets only deepens them. This is the challenge of observing a comet's nucleus. The nucleus of 3I, Atlas, is likely only a few miles across a tiny dark object in the vastness of space. But its coma, the misty atmosphere it generates, can swell to be thousands, even hundreds of thousands of miles wide. We are trying to spot a single dark pebble at the bottom of a vast, glowing, misty pond. Our most powerful telescopes, like Hubble, are drawn to the beautiful light of the coma, but that light overwhelms the faint, reflected sunlight bouncing off the tiny, solid core. The closer it gets to the sun, the more active it becomes, the brighter its coma shines, and the more impossible it becomes to pierce the veil. So, how do we know anything about it? We estimate. It is a gentle, deductive art. By measuring the brightness of the coma, astronomers can calculate how much gas and dust is being produced every second. From that, they can work backwards, guessing at the size of the active surface area on the nucleus required to produce such a cloud. It is like standing in the dark and trying to guess the size of a bonfire just by the amount of smoke and light it's throwing into the sky. You can't see the logs, but you can make an educated guess. The estimates for 3I, Atlas, suggested a nucleus, perhaps 5 to 10 miles, in diameter, a significant, city-sized mountain of ancient ice. In other words, the very process that made 3I, Atlas, so magnificent to us was the same process that guarded its deepest secrets. Its beauty was its disguise. The heart of the visitor, The true physical substance of this traveller from another star remained a mystery. Its texture, its shape, whether it was a single solid body or a loose collection of icy rubble, all of this was left to our imagination, hidden behind a curtain of its own breath. Its true size, its rugged and ancient shape, remains a gentle secret hidden in the light. But the clues in that light whispered a deeper, more speculative story, a hint that this unseen heart might not be a simple comet, but a fragment of something much larger. As we drift now from the observable facts into the gentler, more speculative currents of scientific thought, a wondrous and provocative idea begins to take shape. What if 3I, Atlas, was not just a comet? What if its unusual chemical signature, its significant size, and its ancient origins were all clues pointing to a more dramatic and complex history? What if this visitor was not just a leftover building block from the formation of another solar system, but a true fragment of a finished world, a piece of a long-shattered exoplanet? Let's allow our imaginations to journey back, billions of years ago, to its unknown home system. Imagine a world much like the icy moons of our own Jupiter or Saturn, a planet-sized body with a rocky core and a thick, miles-deep mantle of ice. Perhaps it had a subsurface ocean, warmed by tidal forces from its parent star or nearby gas giants. It would have been a geologically active world, with cryovolcanoes erupting plumes of water, nitrogen and carbon dioxide into its thin atmosphere. Over eons, the heavier elements, like nickel and iron, would have settled toward its core, while the lighter, volatile ices remained on top. It would have been a complex, differentiated world, a place with its own history and geology. Now, imagine a cataclysmic event in the later life of that solar system. Perhaps two of these icy worlds collided in a slow, majestic, and utterly destructive impact. Or maybe a wandering star passed too close, its gravity violently disrupting the orbits of the outer planets, tearing one of them apart. In this cosmic chaos, the planet is shattered. Huge fragments are thrown out into interstellar space, each one a shard of that broken world, a piece of its history blasted into the void. Our visitor, 3I, Atlas, could be one of these fragments. This idea, while speculative, is not pure fantasy. It offers a beautiful, unifying explanation for some of the comet's mysteries. The unusual abundance of carbon dioxide could be a signature of its ancient planetary atmosphere frozen onto its surface. The presence of gaseous nickel in the coma could be explained if the fragment was a piece of the planet's mantle or core, a deeper layer excavated in the cataclysm that was then exposed to the sun's heat. It would no longer be just a comet, a simple snowball of primordial ice, but a piece of planetary wreckage, a true ruin from a lost civilization of rock and ice. In other words, we might not have been looking at a simple message in a bottle, but a piece of the ship itself. It's the difference between finding a random seashell on the beach and finding a piece of carved driftwood that was clearly once part of a larger, more complex structure. The object in our sky becomes an artifact, a piece of extraterrestrial geology, a tangible sample of an alien world's anatomy. What this really means is that interstellar visitors like 3I, Atlas, could be our only way of ever touching a planet from outside our solar system. They are the universe's own sample return mission, delivering pieces of distant worlds to our doorstep free of charge. We are no longer just studying the building blocks of planets. We may be studying the planets themselves, in pieces, and the place where such ancient worlds might have formed adds another layer of wonder to the story. To deepen this sense of ancient planetary origins, let's return to that quiet, older neighborhood of the galaxy where 3I, Atlas, likely began its journey, the galactic thick disk. This is not just a location in space, but a location in time. To speak of the thick disk is to speak of the Milky Way's adolescence, a period billions of years before our sun even existed, when the universe was a profoundly different place. Let's return to our analogy of the galaxy as a vast, sprawling city. The thin disk, our home, is the modern, gleaming downtown. It was built with recycled materials, the dust and gas left behind by countless generations of older stars. This material is rich in what astronomers call metals, which to them means any element heavier than hydrogen and helium. The abundance of these heavy elements in our neighborhood is what allowed rocky planets like Earth to form, providing the raw materials for iron cores, silicate crusts, and complex chemistry. Our solar system is a product of this rich, modern, recycled environment. The thick disk, however, is the city's old town, its historic quarter. The stars there are the city's founding generation. They were born from the galaxy's original, more pristine clouds of gas, which were much poorer in these heavy elements. The first stars had to create these metals inside their fiery cores and then scatter them through space when they died. So, a solar system forming in the thick disk 10 billion years ago would have been built from a very different recipe book. The ingredients available to form planets would have been subtly, but fundamentally, different. Perhaps in that ancient, metal-poor environment, the formation of giant Jupiter-like planets was less common, leading to solar systems with different, less stable architectures. Or perhaps the planets that did form had a different chemical makeup worlds, richer in carbon and oxygen, with different kinds of cores and mantles. The geology of a planet is determined by its ingredients, and the ingredients in the thick disk were from an older, simpler pantry. In other words, the origin of 3I, Atlas, in this ancient region is not just a curious detail, it is a profound clue. It suggests that the alien chemistry we detected in its coma might be the signature of a bygone era of planet formation. It's not just from another place, it's from another time, a time with different rules and different materials. It is a chemical fossil of a much younger galaxy. What this really means is that our visitor was a bridge to a past we can never directly observe. It was a tangible piece of the early universe, delivered to our present. By studying this fragment of a potentially ancient, shattered world, we are doing a kind of galactic archaeology. We are sifting through the ruins of a home that was built in a different epoch of cosmic history, learning not just about other worlds, but about the history of all worlds, including our own. The existence of this one ancient wanderer begs a quiet, humbling question. Just how many more of them are out there, silently drifting in the dark? The discovery of 3I, Atlas, following so closely on the heels of Oumuamua and Borisov, paints a picture of a galaxy that is far from empty. It suggests that the space between the stars is not a sterile void, but a vast, dark river, filled with a slow, invisible current of these wandering objects. For everyone that happens to pass through the tiny, brightly lit harbour of our solar system, there must be an unimaginable number of others that drift by, unseen in the surrounding darkness. Let's go back to our quiet, dawn-lit beach one last time. For centuries, you have lived on this island, and you have never seen anything wash ashore that wasn't from the island itself. A familiar seashell, a piece of local driftwood. Then, one day, you find a strange bottle from an unknown land. It's a miracle, a once-in-a-lifetime discovery. But the very next year, another, different bottle washes up, and a few years after that, a third. You would not conclude that you are just incredibly lucky. You would conclude that the ocean is full of bottles. You would understand that your small, familiar beach is just one tiny stretch of coastline on a vast, interconnected world, and the currents are constantly carrying things from shore to shore. Your perspective would shift from a sense of isolation to a sense of profound connection. This is the shift in understanding that these interstellar visitors have given us. Our solar system is a very small target in the immensity of the galaxy. The fact that we have now seen 3 such objects in just a few years, now that we have telescopes powerful enough to look for them, implies a staggering number of them must be out there. The calculations, based on this tiny sample size, are mind-boggling. Some astronomers estimate that at any given moment, there could be trillions upon trillions of interstellar objects passing through our own solar system, most too small and too dark to ever be detected. The space within the orbit of Neptune might contain thousands of Oumuamua-sized objects at all times, all just passing through. In other words, the galaxy is constantly shedding. Every star system, in its violent, chaotic youth, likely ejects countless comets and planetary fragments into interstellar space. These objects then wander for eons, becoming a kind of free-floating galactic population of nomads, belonging to no single star, but to the galaxy as a whole. They are the seeds of worlds, scattered on the cosmic winds. What this really means is that the void is not empty, it is a repository. The space between the stars is a dark, cold and silent museum of cosmic history, filled with the lost and exiled fragments of a billion worlds. We have only just opened the door to this museum and have caught a fleeting glimpse of 3 of its exhibits. It fosters a sense of humility and of immense possibility. The universe is not just a collection of static, isolated islands. It is a dynamic, interconnected ecosystem, constantly sharing and exchanging physical pieces of itself. And this quiet, constant exchange can be thought of in a new way, as a kind of message service, a way for the galaxy to communicate with itself. This steady, silent rain of interstellar visitors can be seen as something more than just cosmic debris. It can be thought of as a form of galactic communication, a quiet, physical messaging service that operates on a timescale of billions of years. These are not intelligent messages, of course. They carry no encoded information, no greetings from alien civilizations, but they are messages nonetheless. They are geological telegrams, physical samples of other worlds delivered directly to our scientific instruments. They allow us to learn about the nature of distant star systems in the most direct way possible, by touching, or at least tasting, a piece of them. Imagine you are a historian, living in a small, isolated village, trying to understand the nature of the vast unknown world beyond your valley. You can see the distant mountain ranges, you can study the light from them, but you can never travel there. Then, one day, the river that flows through your valley begins to carry things from those mountains. A strange red stone washes ashore, telling you about the geology of the high peaks. A uniquely shaped leaf floats by, a clue to the kinds of trees that grow in the unseen forests. A fragment of pottery, worn smooth by the current, hints at the cultures that might exist upstream. You would not be receiving a letter, but you would be receiving invaluable information. The river itself would become your messenger. In the same way, the galaxy is the river, and these interstellar objects are the artifacts it carries. Until now, our only way to study the planets around other stars' exoplanets has been indirect. We watch for the tiny dip in a star's light as a planet passes in front of it. We study the slight wobble of a star, caused by the gravitational tug of its unseen worlds. It is like trying to understand the nature of that red stone in the mountains by studying its shadow from miles away. But with an object like 3I, Atlas, we have the stone itself. We can analyze its composition, its density, its isotopic ratios. We are doing hands-on, extraterrestrial geology on a world we can never see from the comfort of our own solar system. In other words, the galaxy is giving us free samples. Each interstellar object is a biopsy of its home star system. Oumuamua might have been a sample of a rocky inner planet, Borisov a sample of a familiar, icy outer region, and 3I, Atlas, a sample from a much more ancient world, perhaps a fragment of a differentiated planetary body from a bygone cosmic era. Each one adds a data point to our understanding of how worlds are made, not just in theory but in practice. What this really means is that our own solar system is a laboratory, and the universe is providing the specimens. We are no longer limited to studying our own 8 planets to understand planetary science. We now have access to a trickle of exoplanetesimals, each one a new and unique clue. This reframes our place in the cosmos. We are not just passive observers looking out, but active recipients of a slow, steady stream of physical information from the great beyond. And each piece of that information allows us to dream, to speculate, and to imagine the kind of home that would create such a messenger. The chemical secrets locked within 3I, Atlas, whispering of its ancient and distant home, invite us into a realm of gentle, informed speculation. We can use these clues, like archaeologists piecing together a lost city from a few recovered artifacts, to paint a soft focus picture of the solar system it left behind. We cannot know its name or its precise location, but we can imagine its nature, letting the science guide our daydreams. The high concentration of carbon dioxide ice, for instance, is a powerful clue. Carbon dioxide freezes at a warmer temperature than more volatile gases like carbon monoxide. This might suggest that 3I, Atlas, formed in a region of its protoplanetary disk that was relatively warm, perhaps closer to its star than our own comets were to the Sunday. Imagine a young, bright star, hotter and more brilliant than our own. The snow line for carbon dioxide would be pushed further out, creating a vast, rich reservoir of this specific kind of ice. Our visitor might have been born in that specific carbon-rich zone, a product of a warmer, brighter stellar nursery. Or perhaps the story is about the star itself. The unusual presence of vaporized nickel in the coma could be a reflection of the parent star's own composition. Stars are not all created equal. Some are born from gas clouds that are richer in heavy elements metals than others. If the parent star of 3I, Atlas, was unusually metal-rich, then the entire disk of material from which its planets and comets formed would have been enriched with elements like nickel. Our visitor would simply be a pristine, frozen sample of that original, metal-rich cloud. It would be a child that inherited its parents' unusual chemistry. Let's picture this home system. A brilliant hot star, perhaps, surrounded by a swirling disk of gas and dust laced with a higher-than-average amount of nickel and carbon. In the outer regions, planets are forming, their immense gravity beginning to stir the pot, flinging smaller icy bodies, like 3I, Atlas, into chaotic orbits. We see it not as a lonely wanderer, but as a young resident of a busy, dynamic, and chemically unique home. A home that was perhaps destined for a more violent and unstable future than our own. Its very existence, as an exile, hints that this system was a place of great gravitational upheaval, a place where planets migrated and jostled for position, clearing the celestial neighborhood by ejecting their smaller siblings. In other words, we are using the comet as a lens, turning it around and trying to focus it on a place we will never see. Its composition is the faint, blurry image in that lens. We can't make out the details, but we can see the broad strokes, the colors, the light, the general feel of the landscape. It's a deeply human act to take a single, lonely object and build a world around it, a home to send it back to in our minds. What this really means is that 3I, Atlas, is a catalyst for our cosmic imagination. It reminds us that our solar system is not the only template. The universe is endlessly creative. There are likely star systems with different chemistries, different architectures, and different histories. And now, our visitor, having shared its quiet story with us, must continue on its own journey, its next chapter unfolding as it swings around our sun and prepares for its long, slow departure. Every journey has its turning point, and for 3I Atlas, that moment was its perihelion, its closest approach to our Sunday. After a long, slow fall that lasted for eons, it finally reached the bottom of the sun's gravitational well. For a brief, fiery moment, it was bathed in the full, glorious power of a star, a crescendo in its quiet, lonely existence. And then, its immense, untetherable momentum carried it forward, and it began to climb. It started its long journey back out, away from the light, its visit to our solar system already beginning to recede into its past. Imagine a migratory bird, driven by ancient instinct, on a journey that spans a continent. For a few short weeks, it finds a temporary home in a sun-drenched southern marsh. It rests, it feeds, it is a vibrant, active presence in this new landscape. But it was never meant to stay. The same instincts that brought it here soon call it to leave. One day, it lifts into the sky and begins its long, patient flight back to the north from which it came. Its departure is not a sad event. It is a natural, necessary, and beautiful part of its cycle. It is simply continuing its journey. The departure of 3I, Atlas, is just like this. It was never a resident, never a captive of our sun's gravity. Its visit was always destined to be temporary. As it swung around the sun, the geometry of its path was a near-perfect mirror of its arrival. It would cross the orbits of the planets once more, but this time in reverse order. Venus, then Mars, then Jupiter, and Saturn. As it travelled outwards, its speed would slowly decrease, gravity now acting as a gentle brake, pulling it back, but never with enough force to stop it. It was paying back the velocity it had gained on its fall, but it would always have enough of its original, interstellar speed to ensure its escape. From our perspective on Earth, we would watch it slowly fade. As it moved further from the sun, the warmth that had animated it would dwindle. The sublimation of its ices would slow, and its beautiful coma would begin to shrink and dim. Its magnificent tails, starved of new material, would dissipate into the void like smoke from an extinguished flame. Over months and then years, it would grow fainter and fainter in our telescopes, its light slowly being reclaimed by the darkness. Eventually, it would become just another faint, moving point of light, and then nothing at all. It would be gone, swallowed by the same infinite black ocean from which it emerged. In other words, its departure is as much a part of its story as its arrival. It is the quiet, meditative final chapter of its time with us. The show was over. The comet was returning to its natural state, a silent, frozen, and solitary wanderer in the great, dark void. We were simply privileged to have a front row seat for its one brief performance. What this really means is that our connection to this object was always fleeting. We intersected its timeline for a cosmic instant. We learned what we could, we marveled at its beauty, and now we must let it go. Its journey continues, back into the interstellar night, carrying with it the faint, microscopic scars of its encounter with our sun, a silent memory of the one time, in billions of years, that it came into the light, and as it fades, it leaves us to reflect not just on its journey but on our own. As the light of 3I, Atlas fades and its story becomes a memory, we are left to ponder the deeper meaning of its visit. We have followed its journey across unimaginable distances, through the cold of interstellar space and into the warmth of our cosmic home. We have marveled at its alien chemistry and its ancient origins. And yet, in the quiet afterglow of this encounter, a simple, profound, and deeply comforting realization can begin to settle in. For all its strangeness, for all its foreignness, this visitor was made of the same fundamental things that we are. The light from its coma told us of carbon, the backbone of all known life. It spoke of nitrogen, a key component of our atmosphere and our DNA. It showed us oxygen, locked away as water ice, the same molecule that fills our oceans and sustains our bodies. Even the surprising nickel, in its vaporized gaseous form, is an element forged in the heart of an ancient dying star, just like the iron in our blood. Though it was born in a different time, in a different place, under a different star, it was built from the same universal set of ingredients, the same stardust. Imagine finding that message in a bottle on the beach. The bottle is made of a strange foreign glass, and the script inside is in a language you cannot read. But as you study the ink on the parchment, you realize it is made from carbon, the same element that makes up the charcoal in your own fireplace. The parchment itself is made of cellulose, the same organic polymer that forms the trees in your village. Suddenly, the message feels less alien. You cannot understand its words, but you understand its substance. You realize that the distant, unknown land it came from must share a fundamental chemistry with your own. It fosters a feeling not of strangeness, but of kinship. In the same way, 3I, Atlas reminds us that we are not separate from the cosmos. We are a part of it. The laws of physics and chemistry are not local ordinances, they are universal truths. The processes that built our world, the fusion in stellar cores, the coalescing of dust and gas in a protoplanetary disk, are the same processes that built its world. It is a quiet, humbling reminder that the entire galaxy is a single, interconnected ecosystem, operating on a shared set of principles. In other words, our visitor was a mirror. In its alien face, we could see a reflection of ourselves. It was a tangible link in the great chain of cosmic creation, connecting our small, familiar world to the vast, unseen network of other worlds that surely populate the galaxy. It crossed the immense silent gap between the stars, to show us that the gap is not as empty or as alienating as we might have thought. What this really means is that the story of 3I, Atlas, for all its cosmic grandeur, is also an intimate human story. It brings the vastness of the universe down to a personal scale. It reminds us that the carbon atom in our hand and the carbon atom in a comet from another star share a common ancestor in the heart of a long-dead Sunday. We look up at the night sky not as outsiders peering in, but as members of the family, recognizing a distant, long-lost cousin who came to visit for a little while. And the story of how we met this cousin is, itself, a quiet testament to the human spirit. The story of 3I, Atlas, is not just the story of a comet. It is also a quiet human story, a tale of patience and curiosity. The discovery was not a thunderclap, not a sudden dramatic event that shook the world. It was the result of a slow, steady, and deeply meditative process, a testament to the quiet power of methodical observation. It's a story about the people and the machines who spend their lives looking up, sifting through the silence, waiting for a whisper. Let's return for a moment to that quiet observatory on a Chilean mountaintop, to the gentle, rhythmic hum of the Atlas telescope. Imagine the software engineers who wrote the millions of lines of code that allow the telescope to scan the sky, to compare images, to notice the one faint smudge that is moving just a little too fast. Think of the astronomers, perhaps sitting in a quiet office thousands of miles away, sipping coffee in the middle of the night, their eyes patiently scanning the day's new batch of flagged objects, their minds trained to see the subtle signature of something new, something that doesn't quite fit. There is no grand adventure here, no heroic journey. There is only the patient, collective application of human intellect and curiosity. This is the gentle art of discovery in our modern age. It is a global collaboration, a quiet conversation happening between robotic eyes on lonely mountains and human minds in scattered universities, all connected by the silent flow of data. The discovery of 3I, Atlas, belongs to no single person. It belongs to a system, a network of patience. It is a story about the deep, unwavering human need to understand, to map the darkness, to simply see what is there. In a world that often prizes speed, noise, and immediate results, the discovery of 3I, Atlas, is a beautiful counterpoint. It is a reminder that the greatest truths are often revealed not in a flash, but through a slow, steady gaze. It is the reward for decades of building better telescopes, writing smarter software, and training generations of scientists to look at the sky with both rigor and wonder. It is a story about the quiet, behind-the-scenes work that makes these breathtaking moments of connection with the cosmos possible. In other words, the comet's long, patient journey through space was met by an equally long and patient human journey of technological and intellectual development. Two long, slow paths, one of ice and rock, the other of thought and effort, finally intersected on a summer night in 2025. It was a meeting billions of years in the making. What this really means is that the wonder of 3I, Atlas, is twofold. There is the wonder of the object itself, its age, its origin, its fleeting beauty. But there is also the quiet, profound wonder of our own ability to have seen it at all. It is a story that fosters a gentle sense of gratitude for the quiet, persistent, and often anonymous work of science, the slow and steady accretion of knowledge that allows us, for a brief moment, to shake hands with a visitor from another star, and in doing so, that visitor helps us see our own home in a new and precious light. In the end, the greatest gift of a visitor is not what it tells us about its own home, but what it reveals about ours. By showing us what else is possible, by presenting us with a different way of being, a visitor holds up a mirror to our own world, forcing us to see our familiar surroundings with fresh eyes. 3I, Atlas, in all its ancient, icy strangeness, did exactly this for our solar system. Its brief passage was a quiet lesson in the preciousness and perhaps the rarity of our own cosmic home. Its existence as a lonely exile, flung from its home by gravitational chaos, is a gentle reminder of the remarkable stability we enjoy. Our solar system is a place of serene, predictable orbits. Our giant planets, Jupiter and Saturn, settled into their peaceful paths long ago, and now act as gentle shepherds, protecting the inner planets rather than threatening them. We live in a calm, mature harbour, a place of quiet order. Tall 3i, Atlas comes to us from a place that was, or perhaps still is, a stormy sea. Its journey highlights the gentle gravitational architecture that makes our long-term stability possible, a stability that was a crucial ingredient for the slow, patient evolution of life on Earth. Its strange chemistry, so rich in volatile ices and exotic metals, accentuates the specific and delicate chemical balance of our own world. Our planet exists in the perfect Goldilocks zone, where water can be a liquid. Our comets delivered that water, and our planet was able to hold on to it, creating the oceans of our world. The story of 3i, Atlas, a story written in carbon dioxide and nitrogen ice, reminds us that the ingredients for worlds can be mixed in many different ways, but only a very specific recipe seems to lead to a home like ours. Its foreignness makes our own world feel less like a given and more like a gift. Even its fleeting, temporary visit underscores the idea of belonging. 3i, Atlas was just passing through, a tourist on a journey with no end. We, and every rock and river and tree on Earth, are on a journey together, tethered to our sun in a dance that has lasted for billions of years. We are not wanderers, we are residents. We belong here. The encounter with this beautiful, lonely nomad fosters a deeper appreciation for the simple, profound fact of having a home. In other words, the interstellar visitor, by its very nature as an outsider, helps us to define what it means to be an insider. It sharpens the edges of our own identity. We see its path that never returns, and we are grateful for our own looping, cyclical journey around the Sunday. We see its frozen, lifeless state, and we are grateful for the gentle warmth that animates our world. What this really means is that 3i, Atlas, helped us to see our solar system not just as a collection of planets and rocks, but as a coherent, interconnected, and perhaps very special place. It was a cosmic stranger who, by its brief and silent passage, made us feel more at home in the universe. And in the end, it leaves us with the most beautiful gift of all, a deeper and more profound sense of mystery. As the story of 3i, Atlas comes to a gentle close, we are left not with a neat set of answers, but with a series of beautiful, echoing questions. And perhaps this is the most valuable gift the visitor leaves behind. In science, as in life, the deepest truths are often found not in the finality of an answer, but in the slow, wondrous unfolding of a mystery. Our visitor, in its silent passage, deepened our appreciation for the vast, quiet beauty of the unexplained. We still do not know, and may never know, the name of the star it once called home. We can guess at its general neighbourhood in the galaxy's ancient thick disk, but the specific, individual sun it once orbited is lost to time and distance. Its home is a ghost, a nameless, placeless point of origin that exists only in our imagination, built from the faint chemical clues it left behind. And there is a profound beauty in that anonymity. It represents all the countless unknown worlds that populate our galaxy, each with its own story, its own history, forever beyond our reach. We do not know the true shape and nature of its heart. The nucleus, forever veiled by its own glowing coma, remains a secret. Was it a solid, cratered mountain of ice? A loose, porous rubble pile barely holding itself together? A shard of a shattered planet with a strange, uneven form? We can only guess. Its true face was never shown to us, leaving us with a sense of wonder about the physical nature of these ancient wanderers. It is a reminder that even when an object is right in front of us, some things remain hidden, inviting us to imagine rather than to know, and we do not know its ultimate fate. As it travels back out into the interstellar void, what will become of it? Will it wander for another billion years, a silent, frozen ghost, until it happens to pass through another star system, in a future so distant we cannot comprehend it? Or will its journey be shorter? Will it, over eons, be ground down to dust by collisions with interstellar grains, its substance slowly and gently return to the galactic medium from which it was born, its future is as unknown as its past. It is a story without a clear beginning or a certain end, and we were simply privileged to witness one chapter in the middle. In other words, 3I, Atlas, was a lesson in humility. It reminded us that the universe is not a simple puzzle to be solved, but a vast, complex poem to be experienced. For every fact we could glean from its light, there were a dozen new questions that blossomed in the darkness. Science is not a march toward omniscience, but a deepening relationship with mystery. What this really means is that we can find a deep and abiding peace in the act of not knowing. We can let the unanswered questions hang in the quiet air of our minds, not as problems to be solved, but as sources of gentle, endless wonder. The story of 3I, Atlas, is not diminished by its uncertainties, it is magnified by them. It becomes a story not just about a comet, but about the beautiful hazy frontier between the known and the unknown. And at the heart of it all is the simple, breathtaking fact of the encounter itself. In the grand, silent, and impossibly long story of the universe, the brief intersection of our path with that of 3I, Atlas, is a moment of near miraculous coincidence. Let us just rest in the quiet contemplation of that single fleeting connection. For a cosmic instant, two entirely separate, unrelated journeys, born light years and perhaps billions of years apart, happened to cross, and we were here to see it. Imagine two single grains of sand, each on a different continent, washed into a different river. The rivers flow into the great churning ocean, and the grains of sand are carried by the currents for 1,000 years, tossed and turned in the vast dark waters. The chance that these two specific grains of sand would ever touch, even for a moment, in the immensity of the world's oceans, is practically zero. It is a statistical impossibility. And yet, the journey of 3I, Atlas, and the journey of humanity represent a coincidence on a scale that dwarfs even this. Our visitor's journey began in a star system that no longer be a memory, flung into the void on a random trajectory. It travelled a path of unimaginable length, a thin, invisible line drawn across the fabric of the galaxy. Meanwhile, on a different spiral arm of the same galaxy, our own solar system formed, our planet cooled, and life slowly, painstakingly, emerged from its oceans. Over millions of years, that life evolved, developing consciousness, curiosity, and eventually the tools to look up at the sky with understanding. Our own journey, the human journey, is its own thin, improbable line drawn through time. For the briefest of moments, these two lines crossed. The ancient, icy wanderer, on its billion-year voyage, happened to pass through this one tiny, specific, life-filled solar system, at this one tiny, specific moment in history when a species was present that could not only see it, but understand what it was. 100 million years earlier, it would have sailed by unseen, its passage noticed only by the silent, unthinking pull of gravity. 100 million years from now, it will be long gone, and who knows what eyes, if any, will be here to look up. In other words, the encounter was a perfect, improbable alignment of time and space. It was a cosmic appointment, kept unknowingly by both parties. It required the comet's random, chaotic path to intersect with humanity's linear developmental path at the precise moment of our technological awakening. There is no destiny or purpose in this. There is simply the breathtaking, humbling beauty of chance. What this really means is that we are profoundly lucky. We live in a privileged moment. We are the generation that is finally able to see these messengers from the deep, to recognize them for what they are, and to begin to read their quiet stories. The visit of 3I, Atlas, was a gift of cosmic timing, a reminder that the universe, in its vast, silent indifference, can sometimes produce moments of connection that feel like pure, unadulterated magic. And now, as our visitor fades, we are left to turn back to the question that started it all, seeing it now in a new and gentler light. And so, we circle back to the quiet question we began with, under the soft imagined light of 1,000 distant stars. What is 3I, Atlas, and where did it come from? We have followed its path, from its discovery as a faint, fast-moving smudge of light, to its fiery passage around our sun and its slow, inevitable fading into the darkness. And now, at the end of this long, soothing journey, we find that we don't have a simple answer. We don't have an address. We don't have a name for its home. But what we have is something far more precious. We have a story. We know now that 3I, Atlas, was more than just a comet. It was a messenger from the deep past, a refugee from a star system born in a different cosmic era. It was an ancient icy mountain, ejected from its home by the chaotic gravity of forming planets, and sent on a lonely, silent journey that lasted for perhaps billions of years. Its journey was a long, cold and dreamless sleep, an eon of suspended animation as it drifted through the vast, dark river that flows between the stars. We know that its arrival in our solar system was a gentle, beautiful awakening. For the first time since its violent birth, it felt the warmth of a star, our star. This warmth stirred the ancient volatile ices on its surface, causing it to exhale a glowing, ghostly cloud, its coma a visible breath held for an unimaginable time. And in the light of that breath, we read a quiet, chemical story of its origins, a story written in a familiar alphabet, but with a strange and wondrous dialect, a story of carbon and nickel that hinted at a home that was profoundly different from our own. We followed its path, a perfect untethered arc that confirmed its identity as a true interstellar visitor, a tourist just passing through. We saw it bloom in the darkness, sculpt its own aura into a teardrop of light, and paint two ethereal tales against the velvet of space, one of dust, one of gas, each telling its own tale of the sun's invisible influence. And then we watched it fade, its journey with us complete, as it began its long, slow climb back into the infinite starry ocean. So, where did it come from? It came from a place of chaos and creation. It came from a lost time, from the youth of our galaxy. It came from the cold, and for a moment, it lived in the light. It came from the great silent elsewhere, and its brief presence here made our own home feel a little less lonely and a great deal more wondrous. The answer to our question is not a location, it is the journey itself. And now that journey continues, as the messenger we met for a moment recedes into the distance like a bottle returning to the sea. Let us end our story back on that quiet, imagined beach at the edge of an infinite ocean. The sun is now a soft glow on the horizon, the dawn has passed, and the day is beginning. The strange, alien footprints in the sand are already starting to soften, their edges blurred by the gentle sea breeze. And the message in a bottle, the one you found washed ashore from an unknown land, now rests gently in your hands. You have studied it all morning. You've marvelled at the strange glass of the bottle, you've puzzled over the unfamiliar script on the parchment inside, and you've breathed in the faint exotic scent of its distant home. You have learned all you can from it, and you know it does not belong here. It is a child of the ocean, a creature of the currents, and its journey is not over. And so, with a feeling of gentle reverence and a quiet sense of gratitude, you walk back to the water's edge. The waves are calm, sighing softly as they slide up the sand. You hold the bottle for a moment longer, a final, silent farewell to the mystery it represents, and then you gently place it back into the water. You watch as a small wave lifts it, rocks it for a moment, and then begins to carry it away. It bobs on the surface, a dark shape against the morning light, drifting slowly but surely back out into the great grey expanse. It gets smaller and smaller, until it is just a tiny speck, and then it vanishes completely, reclaimed by the vastness from which it came. You are left alone on the shore, but you are not the same. The beach feels different now. The ocean no longer seems like a boundary, but like a bridge. You know now that your small, familiar island is connected to a whole world of other shores, other lands, other stories, all carried on the same silent, patient currents. This is the final chapter of 3I, Atlas. We watched it wash ashore, a messenger from the cosmic ocean. We studied it, we learned from its strange and beautiful nature, and we felt a fleeting, wondrous connection to its unknown home. And now, we have watched it swing around our sun and begin its long, slow journey back out into the deep. We let it go. Its story in our skies is over. It returns to the quiet, the cold, and the dark, carrying on its endless silent pilgrimage through the galaxy. Its visit was a gift, a brief intersection of two impossibly different journeys, and now the bottle is drifting away again, back into the great, quiet ocean of the stars, leaving only a sense of peace and of profound, gentle wonder. As the last faint glimmer of our visitor fades from our minds, the story of 3I, Atlas, dissolves back into the deep and quiet darkness from which it came. The questions it raised do not demand answers now. They hang in the air like distant, sleeping stars, content to simply be. The vast cosmic river flows on, silent and slow, carrying its countless other secrets through the night. There is nothing left to follow, nothing left to solve. There is only the gentle, lingering sense of connection, the quiet awe of having witnessed a brief chapter in a story that is billions of years old. Let that feeling be a soft, warm blanket. Let the immense scale of the journey soothe you, a reminder of how small our worries are in the grand, silent turning of the galaxy. Our own small world continues its patient, looping path around our sun, a tiny precious harbour in an ocean of wonders. And you, in your own quiet space, can now let your own journey drift, letting go of thought, letting go of the day. The universe will continue its silent, graceful dance. The stars will continue to shine, and you can rest, you can sleep. Let the darkness be a comfort, a quiet harbour for your own dreams. Sleep well.